Hello students, welcome to the class of mathematics where we will be studying about quadratic equations. So I will be starting with the introduction. My name is Utsav Sir and I will be teaching you about quadratic equations. Well, first of all, we would understand about quadratic equation. How does it look like? What is the general basic form of a quadratic equation? So this is a quadratic equation. Ax squared plus bx plus c. This is a quadratic polynomial. If I'm equating this with 0, so this becomes quadratic equation. Now here A is called coefficient of x squared, which is called, which is the deciding factor of this quadratic polynomial. If A is greater than 0, the graph would be opening upward. If A is less than 0, the graph would be opening downward, just like smiley face. And this we call it sad face. This is sad face. This is smiley face. Okay. So this is called quadratic coefficient. And this is called B, that is called linear coefficient. And this is called constant. Now, this quadratic equation we use in whenever we want to find the profit or we want to maximize the profit in any business or any economical things we are using it. So this is the basic example of a quadratic polynomial. Now there is a term called discriminant. That is nothing but d is equal to b square minus 4ac. Now depending on the sign of d, that if d is greater than 0, d is equal to 0 and d is less than 0, we can have different form of roots. Now you may ask, sir, what is a root? Roots are those x values where the curve y is equal to fx crosses the x-axis. For example, if we have anything like this ax squared plus bx plus c, and the graph of this curve look like this. So this is alpha, this is beta. So here we call it alpha as a one root, beta as another root. This quadratic polynomial can have at max two roots. It cannot go beyond two. It can have max to max two roots. It cannot be more than two. If the roots are more than the degree of a quadratic polynomial, that means that would become an identity. That won't be the equation. We won't be calling that as an equation. If any polynomial, if any quadratic polynomial n degree, if the degree of a polynomial is n, and if they are having n plus roots, n plus 1 roots, that means that polynomial would be termed as an identity. So, if d is greater than 0, we have real roots. If d is equal to 0, we would have roots are real plus equal. If d is less than 0, roots are imaginary. Now, we would be checking if this is in the form of a quadratic equation or not. X into x plus 1 plus 8 is equal to x plus 2 into x minus 2. First solve this. X square plus x plus 8 is equal to x square minus 4, because a square minus b square is a plus b, a minus b. So x square got cancelled. So here I got as x plus 8 plus 4 is equal to 0. That means this is x plus 12 is equal to 0. This is x equal to minus 12. So this is not, this is not a quadratic equation. If you have any doubt, please let me know. I hope this is clear. So as of now, we have discussed about a quadratic polynomial, basic general description of a quadratic polynomial, how it looks like, what are the graphs of that, opening upward, opening downward, what is the basic form of a quadratic polynomial and quadratic equation, when quadratic equation becomes an identity, that we have also discussed. Okay. Now we have the general form of quadratic polynomial as ax square plus bx plus c. Now, as we know, a quadratic polynomial has two roots. Now they have some relation in between them. That means sum of roots. We call it as SOR, or alpha plus beta is minus b by a. That means minus coefficient of x divided by coefficient of x squared. So this is called sum of roots. Likewise, we have product of roots, that is called alpha into beta, and that is c by a. That is constant upon coefficient of x squared. So suppose we have one question, x square plus 5x plus 6 equal to 0. Now they are asking us to find alpha plus beta and alpha minus beta. So here A is 1, B is 5, C is 6. So alpha plus beta is minus B by A. So minus 5 by 1. Now alpha into beta, that is going to be C by A or 6 by 1. So answer is alpha into beta is 6. Alpha plus beta is minus 5. I hope it's clear to everyone, right? Now you might ask, sir, what are the real life application of this quadratic formula? Why do we study about this? So in daily life, we use quadratic formula for calculating areas, determining a product's profit, or formulating the speed of an object. In addition, quadratic equations refer to an equation that has at least one square variable, that is x squared. So these are some real life applications of a quadratic formula. Now, depending on nature of roots, there are certain things which we need to discuss. First, a polynomial equation has at least one. Second, a polynomial equation of degree n has n roots. So suppose if we have a quadratic polynomial, so it will have two roots, max to max. Now there are certain methods with the help of that we can find the roots. One of them is Siddharth formula. Second is completing the square. And third is factorization. Suppose we have one equation as fx equal to x square plus 4x plus 4. We would be solving this question with all the three methods. First formula is x equal to minus b plus minus b square minus 4ac upon 2a. So here a is 1, b is 4, c is 4. So substitute all the values here. X equal to minus 4 plus minus 16 minus 16 upon 2. So it is going to be minus 4 plus minus 0 by 2 or minus 4 by 2 or minus 2. Here d is 0, so both roots are equal. Now, same question we will solve with this method. The question says, find the roots of the equation x square plus 2 is equal to 0. So if I'm equating it, we were getting x square equal to minus 2. So for real x, it is not possible. This would give you imaginary roots. Okay. Now we had x square plus 4x plus 4 is equal to 0. This we can write it as x plus 2 whole square is equal to 0. That would give us x equal to minus 2 and minus 2. Now, let's solve one question with the help of factorization. Middle term split. So how do we split? X square, 3x plus 2x plus 6. Now, we can take x common. So x plus 3 plus 2 common, x plus 3. So what do we get here? X plus 3 into x plus 2 is equal to 0. So from here, what I get? X equal to minus 3, x equal to minus 2. So these are the roots of polygon, quadratic polygon. Now we will be solving this question. The question is root 5 x square plus x plus root 5 is equal to 0. We need to solve this. So here a is root 5, b is 1, c is root 5. So the formula is minus b plus minus b square minus 4ac upon 2a. So it is going to be minus 1 plus minus b square, that is 1 minus 4ac upon 2 root 5. So here if we see, we are getting minus 1 plus minus minus 19 by 2 root 5. So again, roots are imaginary. Roots are imaginary. So whenever we are getting under root minus 1, that is called iota. This is an operator. So here roots would be minus 1 plus minus under root minus 9. These are non-real roots. Clear? Okay. Now check next question. They are asking us to solve this equation x squared plus x plus 1 is equal to 0. Now again, check a is 1, b is 1, c is 1. So minus b plus minus b square minus 4ac upon 2a. To substitute the values, minus 1 plus minus 1 minus 4 upon 2. So minus 1 plus minus minus 3 by. So it is minus 1 plus minus under root of minus 3 by. So here we will be having roots like this. I'll take plus sign and minus sign. So roots will be minus 1 plus minus under root 3 iota by 2 and minus 1 minus under root 3 iota by 2. Okay. The next question is they have given as fx equal to 2x squared plus x plus 1 is equal to 2. Here a is b is 1, c is 1. So minus b plus minus b square minus 4ac upon 2a minus 1 plus minus 1 minus 4 into 2 by 2 into 1. So it is going to be minus 1 plus minus 1 minus 8 by 4. So minus 1 plus minus under root minus 7. So answer is minus 1 plus minus root 7 iota by. Now this is the question. Find roots using factorization. So we have to find roots using factorization. Okay. So first write the equation 2x square minus 5x plus 3. Now what we will do? We will multiply 2 and 3. So it is 6. So write like this 1 into 6, 2 into 3. Now check if we are adding or subtracting, are we getting minus 5? Yes. If we are subtracting 6, subtracting 1 from 6, we will get 5. And if we are multiplying 6 with minus 1, we are getting 6. But what we want? We want minus 5. So remember this always. So this is how we factorize the form. So here if we check, it would be A they have given us 2, B as minus 5, C as 3. Now, A, we know formula minus B plus minus B square minus 4AC upon 2A. Substitute the value here. So it is going to be 5 plus minus 5 square minus 4 into 2 into 3 divided by 6. So 5 plus minus 25 minus 24 divided by 6. So 5 plus minus 1 by 6. So answer would be 5 plus 1 by 6 and 5 minus 1 by 6. So this is going to be 1 and this is going to be 5 minus 1, 4 by 6, 2 by 3. So these are the factors. That means we can write it as fx equal to x minus 1 into x minus 2 by 3. Now next question is, we need to solve x square plus 4x minus 5 is equal to 0. We have to solve this. So first check, we can write it as 5x minus x minus 5 is equal to 0. Take x common, take minus 1 common. So x minus 1, x plus 5 is equal to 0. So what are the roots? So these are the roots of the quadratic equation. We can check also. Check F1. It is 1 plus 4 minus 5, 0. F of minus 5 also. So 25 minus 20 minus 5. So 5 minus 5 is 0. Roots are satisfying. Hence, answer is 2. Okay. Now they are asking us to find the roots if any exist. So first we will check the D, that is B square minus 4AC. So here A is 1, B is 4, C is 5. So minus B plus minus B square minus 4AC upon 2A. First check D, B square minus 4AC. That is going to be 16 minus 4 into 5. 16 minus 20 minus 12. So here it is minus 4 plus minus 4 upon 2. So real roots does not exist as t is less than 0. No real roots exist. Any doubt in this? Now this is our next question. We need to check if this is forming any quadratic equation or not. Just multiply first. X square plus x plus 8 is equal to x square minus 2x plus 2x minus 4. X square plus x plus 8 is equal to x square minus 4. So it is going to be x square we can cancel out. X plus 8 is equal to minus 4. X is equal to minus 4 minus 8. So x we got is equal to minus 12. That means x plus 12 is equal to 0. Okay. So here we can see that this is not a quadratic polynomial or equation. This is a linear equation. Hence, we can say that this is not a quadratic equation. Now let's solve one more question. Suppose we have fx equal to x square plus 5x plus 6 equal to 0. Now we have to solve. We have to solve it using completing the square. So first what we will do, we know a plus b whole square is a square plus b square plus 2a. So we have to make it as a complete square. So what we will do, x square plus 2 into x into 5 by 2. We divide it and multiply by 2. So this is a square plus 2ab. So this is b. That means we have to square this. And if we are adding something, we have to subtract minus 5 by 2 whole square is equal to 0. So this is nothing but this whole term we can write as x plus 5 by 2 whole square. And here plus 6 is also there. Now plus 6 minus 5 by 2 whole square is equal to 0. So this is x plus 5 by 2 whole square plus 6 minus 25 by 2. So this we can write it here. X plus 5 by 2 whole square minus 24 by 25 or x plus 5 by 2 whole square minus 24 by 25.
Don't forget to like and subscribe.